remember that we kind of talked about the custom standard MBeans and, general how to start with, the basics. Today we're going to add two new, more advanced features. One is creating custom data types, as well as using the notifications, creating notifications for MBeans and how these work within the Coherence management infrastructure. So we'll also have hopefully we'll have some time to show some examples and get to your questions and any other items that you'd like to talk about. So custom data types, they're kind of a pain to create. They're not really, not very intuitive by nature, but they have some really valuable properties. And, the first part is to basically consolidate multiple attributes into a single attribute. Now, we talked on the last one about the inability within JMX to create an auditable set of attributes because the attributes were independent, so they were always time skewed. So if you wanted to do a calculation, size equals, the inserts minus removes minus evictions, you really can't do that calculation and get the accurate answer because the data is always moving across time. But if you put a single attribute, if you use a consolidated data type, you make a single call to the remote server, and you can then synchronize as necessary if you need to just kind of audit calculation. Now, granted, you have to deal with the synchronization issues, but you would be able to get a single MBean back with a single attribute where those inner element calculation could then be done accurately. So it's a great way to use for those kind of calculations. The other parts is if you need to consolidate multiple MBeans or multiple logical MBeans into a single MBean. Now, this is highly successful when doing remote operations. So instead of making many requests over to the other node, you can simply make one request, retrieve multiple data rows, and then use that the consolidated custom data type to actually retrieve the data and loop through and use it as necessary. So it actually will reduce the amount of messages going back and forth within the queue. SL actually used this highly successfully in our custom tables implementation to reduce the number of calls to retrieve caches for large numbers of with clusters with large number of caches. And lastly, the usage is passing context information as part of a notification, which we'll talk about in a minute. There's just a data type, and when you get a notification in, it allows you to pass, what kind of information about the notification that you'd like to do. It's called user data, and it allows you to put it there. So they have some highly valuable usage, even though they're not necessarily the prettiest things in the world. So how do you create one? There's really two parts to it. You can create a composite data type. It's kind of necessary. It defines what the type is, what the rows, what the columns are, the names of the columns, and basically defines that. And then you create the composite data support instance, which is effectively the composite data type plus the data that you're actually going through and using. So it allows you to do that as well. So they're relatively simple, but they're kind of ugly. So I just decided to throw a little code snippet in here where you'll notice that you have to create 4 separate arrays to generate the composite data. You have to create the keys, which is the names of the columns that you're going to reference, the values, which are the actual data that you're going to be supporting. You have to create this description even if you don't use it. So if you wanted to put it blank, you still need to put blank values in there. If these arrays are not the same length, it will actually throw an open data exception down at the bottom. And then the last part is where you're actually creating the open types where it defines the data types. these are the simple type variations. There are, longs, doubles, bytes, dates, etc. that are available within simple types. If you want to do a composite of composites, you actually need to create what's called a tabular data type, which is effectively creating multiple different subtypes within there, and that's a little more complex. I've actually only done it once, so most of the time you can get by with just a simple data type, and that's kind of what we're going through. Create your new data type, passing in some two strings for description purposes, and then you actually just do your composite data for there, and that's how you actually create a composite data type. It's not terribly hard, but making sure that the strings and the times and the values are all lined up would normally took me 30 minutes or so to figure this one out. Hopefully it will take you less to figure out exactly what you want. That's just custom data types. They're relatively simple but kind of ugly. Notifications. So this is where the bulk of this conversation is for today. They were added to Coherence for 3.6. They were part of JMX since, I believe, 1.5. And they basically allow you to monitor thresholds of measurements. So instead of having to have your application constantly poll, you can simply provide a measure where the measure is monitored on the node or on the JMX server, and your client can simply register a listener, and that listener would then be used. So it's for monitoring thresholds. You can do system or application events. An example of this was we added the Coherence event node left, member joined, as part of the Coherence infrastructure, so that we could tell when these things came and went without having to go down and actually join the cluster. And the major benefit from a systemic perspective is they can reduce the use on the network. So if you have a value that you really want to track, say memory, and in the current implementation, you would either have to start up a JMX node on every one of them and basically go around the infrastructure, or you have to sit and constantly pull from the management node, eating up your precious bandwidth that you would much rather use for your application. So what this allows you to do is monitor it as a thread on the managed node, and when the threshold is exceeded, you can simply kick off a notification. So this feature was really added so that we can start managing much larger clusters within Coherence, because once you get to a point where the nodes start getting too large in the 2,000 and 3,000 range, and the caches start getting big, you will start seeing problems. And we thought that this would help us get rid of the minute polls and get us out into the several minute polls, and thus reduce the overhead within management. So how do you create them? First thing you have to do is you have to tell your MBean that it needs to emit notifications. So you do this by basically using two parts of it. Number one is you have to implement the notification emitter, and you also must implement the public MBean notification info array get notification info. You have to do both of these, and the MBean notification info is not part. Get notification info is not part of the emitter interface. It's part of the actual MBean interface itself. And I think you just need to go ahead and implement that method as well. It's already defined. You just need to do so. You also need to create a user data type, create a notification, create a user data type, and call send notification. Send notification is something you don't have to implement because Java provides you a helper class. And the helper class is really nice. It allows you it deals with all the listener registration and unregistration. It also deals with all the send notification methods. So basically, if you extend notification broadcaster support, you can simply call send notification, you can also wrap it up as an attribute within your MBean as well, which if you wanted to implement the entire notification broadcaster interface for you. User data in context is passed using commodity data type. So all this stuff up there at the front, you actually have to, it's a little hokey, and we can show you a little example of this, but basically you create a notification, and the notification instantiation event, the new basically, does not provide a way to actually set the user data. So you have to then create your notification, then you set your user data, and that will send it. The other part of this is you register the MBean with the Coherence registry or the MBean server. This is really nice because you can actually, wherever you're instantiating this thing, whether it's on a managed node or a managing node, you simply register it with the registry, and the Coherence management infrastructure will replicate any of the notifications that get sent out to all managing nodes. Now, the way this works is that when you register it with the registry and a node on the managing node actually registers of the listener, the management service will register a replicator on the managed node and catch any notifications that are true and publish those notifications through using the management service back to the managing nodes. So this allows for basically allowing your MBeans to not really care whether they're on the managing node or the managed node, and they become sort of location independent of their actual of where they reside within the grid. So that's really how you create them. So when you create one of these things, you also need to create notification listeners. Now, listeners, you can either create them, you can use applications, but I'm going to just kind of go over the details of what do you actually have to do to create one of these. You implement notification listener. It's really simple. It only has one implementation. It's called handle, and it gets a notification and a handback. You have to register with the MBean server to receive notifications. So here's the actual call. That's the MBean server add notification listener. You pass the object name, which is the object you want to listen on, the notification that you're going to listen for. You provide a filter, and an object handback. Now, the handback is actually returned to the listener as the object, so the second parameter is then returned. And the filters is a notification filter, and it will filter them at the MBean server. Now, one of the things about the filter is that when you register these with Coherence and you apply the filter isn't applied on the managed node. So if you have a remote MBean that is generating notifications and you want to put a filter on it, that filter only filters it after the notification is sent to the managing server. So it isn't actually moved over to the managed server. So if you're using filters and the notifications are generating lots of notifications, so that's if the MBean is generating lots of notifications, you're going to pay the bandwidth cost within the Coherence grid without the benefit of the filter. So if you're going to use filters, you realize you're still paying the transport of the notification. So that's part of it. And at the end, you need to remove the listener when complete. Oh, one more note I forgot about the add notification listener. The add notification listener, the API says that you can use an object name as a listener. However, the object name, the object that you create, still must implement the actual notification listener. So the MBean that you create must implement notification listener regardless. So just a note on that. It's a little confusing. And at the end, you need to remove your notifications when completed. When you do this, listeners are matched by all parameters, and if you pass only the first two, which is possible, all listeners are removed. So not sure that is, all listeners of that type are removed. So that's just what the general thing. If you don't remove your listener and you just disconnect, Coherence cannot clean up. It doesn't get a notification that the listener has been removed. So once you put a listener on, it starts generating notifications from the managed nodes. If you just hang up and close your app without unregistering, those notifications will continue to broadcast. So you'll start seeing, and I might have time to show you that. You'll actually see there's an attribute within the management MBean that tells you how many remote notifications you received, and that number will continue to click, which is kind of a problem because you're going to continue to burn your bandwidth. So remember to remove your listeners when complete. Okay. Couple things on more things on the notifications. User notification classes must be serializable, and that does not mean portable object. That does not mean externalizable light, and that means all object attributes within the notification must be serializable. This is kind of points to the fact that the management service does not run on POF. It runs on Java serialization for pretty much this reason, because it's transporting objects that are not POFable. So just as a note, you're still going to have to implement serializable for notification classes. JConsole is not a good client. It registers all notifications and filters them on the client, and then they decide to not release any of the registrations. So if you have generated a lot of these items, be wary of JConsole as a client. Use RTView, which will do them. Write your own. Those all get cleaned up, but JConsole can cause you problems if you start doing this. Over notification can consume significant resources. So this is kind of the event problem, which is between annoyance and helpful. You don't want to be annoying. You don't want to burn your system. You need to make sure you get the appropriate level of thresholding when you do it. Most of the time, it's sort of a trial and error. I guess I've been beating this one in the ground. Make sure you unregister your listeners. And the last one we've already talked. So notification filters are filtered, and the managing nodes notifications have been filtered. So how am I doing on time? Oh, perfect. Let's talk about part 3. What we're going to do is we're going to talk about taking our custom MBeans next time and integrating them into RTView. We're going to talk about time skew in MBean data collection, which is kind of one of the details of how to analyze data within Coherence. We'll talk about some overhead and performance considerations of the management service. And we'll hopefully get the code this code snippet and some examples of how to actually build these out probably by tomorrow or the next day. So I am done with my time.
Thank you so much, Everett. Now I'd like to invite the audience to submit any questions at this time by entering them into the Q&A panel and clicking Submit. If we're not able to get to all the questions during the live event, we'll be sure to follow up on any unanswered questions via email.
So, Everett, while we're waiting for people to submit questions, why don't I ask you one? Can you give an example of what a good notification would be, what you would look for in terms of what information would be best received as a notification rather than polling?
Well, I mean, obviously, the ones that I was planning on doing within the Coherence environment was any of the Coherence events. For example, the one that did get implemented was add and remove join. We were looking at probably doing things like publishing the partitioning events as they occur. There were some issues on some of them, which were some threading models, but being able to track, partition lost or when a partitioning event started versus when the partitioning event stopped. Those things would give you a great deal of information in, for example, you want to know once, a common question is, when I did a rolling restart and I brought a new node on, how do I know when I'm completely allocated, right? When did the repartitioning start and stop? Great, good. It's one that I always need to have, which is we added a new node and when did it stop? So those are the common ones that I'm thinking about. Other are just the thresholdings, and the one that the Java implements, which is when you exceed a memory threshold, does it tell you? So coherence events and thresholding of critical attributes.
Okay, and then secondly, in the beginning you talked about complex data types and creating tabular MBeans. Could you talk a little bit about how that can help you in terms of reducing overhead in the cluster and why that would be the case?
What it significantly does is if you are taking, these are when you need all the information. So the coherence management service is optimized for individual MBean retrievals. So if you need one MBean, it works extremely fast. If you need all the MBeans, it has a tendency to get a little chatty because it has to actually request all the MBeans and then process all those requests on the managed nodes. So what it effectively does is reduce the chattiness overhead between the managing node and the managed node. So instead of sending 100 requests for the data information and getting 100 responses, you're simply getting one request and getting one response. Even though the data size is larger, you're getting a less conversation going on between the nodes.
And that conversation between the nodes, what does that burn up? Does it burn up CPU?
Burns up network and CPU. I mean, the network is the packets, as you're sending lots of little packets instead of larger packet sizes. And it also burns up CPU because you're processing those packets on both ends.
Okay, and not to be obvious, but why is it better to send big packets?
Pardon?
Well, why is it better to send big packets rather than little packets?
Bigger packets consume the network more efficiently.
Okay. And I don't see that we have any questions, so why don't we end with a little plug for RTView in terms of how does RTView use the complex data types, and how does that benefit our customers if they choose to use it?
Well, the complex data types are useful in that, A, they provide the more consolidated MBean, so we'll be able to use, calculations will make more sense. And RTView plugs in very easily into the complex data types, and they just look exactly like another another table within RTView. So it's really easy to use them. They, provide a better capability of actually gathering the data. They're worth doing, even though they're a little annoying. So, I do have a couple of examples. Let's see if I can rip one out here that actually shows you a complex data type that is actually running. So, let me fire up a quick cluster. So what I'm just doing is firing up my standard demo. This is just a simple concept, but then we have a complex data type which I'm generating where I don't really know what the total outcome is going to be. So what this is, and we'll probably talk about this in the next seminar, which is here. So what this is an MBean They joined the cluster. And right now I'm just coming back and telling the size of how big the queries are. But when we run this, you look at this one, we have a situation where I'm tracking the performance of each query. And because each one of the queries is running, I don't know exactly what the queries are going to be. So I don't know how many queries are going to actually be there. So I basically have a complex data type where I have n number of queries that are going on in the system. And then I'm tracking statistics about each one of them. So I basically created a cache out there that talks about my process stats that I'm capturing. And I generated a complex data type that has both the cache, the context of it, which is the query, how many times it got executed, and then the total number of nanoseconds and the maximum query time, as well as just some general more information about it. But when you look at these complex data types, they allow me to browse through them in a very dynamic way instead of actually having your standard MBean, which would have simple attributes of each one of them and in an array. So where the arrays do not provide the binding of the data into a logical component, the complex data type gives you this capability. And then you can put multiples on a single MBean, and then you can provide a much more binding of the data instead of sort of the standard way of going about it, which is you sort of put your data out there and try to build it together in a way that doesn't really make much sense, or by some sort of naming convention that keeps the attributes together. So this is my favorite example at the moment of how to use a complex data type to actually show data in a way that's useful. So I think we're at our 30-minute limit. So.
Okay, great. Thank you, Everett. This webcast has been recorded, and we'll be emailing a link to the recording within the next few days. Just a reminder to register for Part 3 of the series. Detailed information can be found on our website at sl.com under News and Events. And thank you, everyone. Have a great day.